Hi everyone. We are going to continue our discussion about the K-means, and we are going to start this lecture notes from the middle because for the first half we have already seen that. I just added a few more things we want to discuss. Okay, so let's go down. Okay, so here, in the last lecture, we tried the n clusters to be two, compare that with the original original labels, and what we found was since three of the clusters they are quite their stayed kind of together here in this area, and it kind of makes sense that we cluster all the samples into two clusters, right? So the next thing is, well, how do we evaluate the clustering result, and how do we know what is the k-value we want to pick? So the first thing we are trying to do is, well, we are trying to for a clustering result, we try to get the sum of the square arrow, or that sum of the squared arrow, or SSE, is also called inertia. So you may see some of this word, the blogs or some other places may use the word inertia. Well, it just means the sum of the square arrow. Okay, so what we want to do is we want to create a function called the Kmeans SSE. So it will take a number as a k-value in the dataset. It will cluster all the samples with the k-means, and then it will for each of the cluster, and then it will get the sum of the squared arrow, or the inertia. Okay, so the very first thing is I find a cool way to do the Euclidean distance. I didn't create this method. I did a Google search and find it's very cool, and I decided I want to take a look on this one. So this is not a function written by myself, and I want to try and see if this function works well. And usually when you grab some other people's code, then you may want to do similar thing. So how to test it? Well, that's very easy. I create one sample and another sample. So that is the xy coordinates 1, 1, and 2, 2, right? So if we want to, I want to call this function and get the distance, and then, well, I should know that the distance between those two samples should be the square root of 2. So I call this function and I got the result, and yes, it is indeed the square root of 2. So, well, I'm going to just use this one for the Euclidean distance. Okay, so the next part, well, I create a function called Kmeans SSE, and I'm taking the number of clusters and then the dataset. And for this part of the code, what I'm trying to do is I try to get the k-nearest neighbor, the k-means model, and then after that, I'm gonna try to for each of the sample in the dataset, I'm going to calculate the distance between that sample to the cluster centroid, and eventually I add everything together, and then I got the total of the squared arrow. And remember, one thing is, well, for this distance matrix, we got the Euclidean distance. So for this part, well, the Euclidean distance is the square root of 2. But if you're trying to get the squared arrow, and then it should be 2 instead of square 2. So in this case, I did a additional powers 2 here. And another thing is, well, I did a divided by 2. Well, remember in the original data set, we have 4 clusters. And then for each of the cluster, we have 50 samples. So there are a total of 200 samples. But if you try to get the size, so if you want to get the size of the dataset, and actually you will have the 400. So I have to do a divided by 2 here. So you may ask, what really happened? Well, this is the rule of the numpy nd array. So in a high dimensional array of the numpy, and if you want to get the size, well, it will tell you how many numbers in total are in the numpy nd array. Okay, so this is an example I created by myself. I created a 3D array which is 3 by 5 by 2. So if I want to get the x dot size, so that is the size of the ND array. So originally, well, I was thinking that if the NumPy works in the same way to the Python list, and then I should get 3. So 3 is a higher degree dimension. But well, in this case, what I really got was a 30. Okay, so how do I know that? Well, to be honest, I didn't know that before I write this code. And when I write this code, and then I got an error here. And then I figure out this error, and by writing down this part of the code, and then I figured it out. Okay, so I'm pretty sure many of you guys have learned foreign languages, and when you learn Spanish or Chinese or uh, Hindi, for example, and well, as a foreign language, you don't want to take a dictionary and then remember everything. And in the world of data science, well, you don't have to do this either. Well, you don't have to know that for ND array, and when you do the size, it is not the top level degree. Instead, it is the product of all the dimensions together. You don't have to know that. But when you have some of the error message, you should be able to write some additional code like this one, and then try to figure that out for yourself. And another part I want to emphasize is here. Well, you guys know me, and I hate copying my own code. And when I see I copy my own code multiple times, and I find, oh, this is really a dirty way of getting the work done. And usually later I'm going to spend time and try to put that into a function. And here I have done this. And for this function, well, we just take two parameters, the how many cluster we want to put the samples into, and then the data set, and then it will return me the total of the SSE and total of the sum of the squared error, right? So, well, if I want to use this part of code in another data set, no problem. I just copy that, and then I can move that to another Jupyter notebook. So, well, remember, as a data scientist, you should be able to write code, of course, and you also need to know how to write good code. Okay, so, well, let's move on. uh, if we want to try to if we cluster all the samples into 10 clusters, and then this is what we got. Okay, so we will have the total SSE, and then it will also show a plot for us. And then for the total SSE 11, we are trying to cluster all the samples into 11 clusters, and then this is the result. So the next part, the question is still there. How do we know what is the k value we want to pick? Well, we still don't know that. However, using the SSE, well, it can give us some idea on how good the clustering result is. Well, and it seems that from 10 clusters to 11 clusters, we are having a lower total SSE. And I want to ask you, if you see a total if you for one cluster, so let's just consider one cluster. For one cluster, if you see the SSE is low, what does that mean? For just one cluster, and you calculate the SSE of all the samples in that cluster, and you find that the SSE is really low, what does that mean? This means all the samples in the cluster are quite close to each other, and all the samples in this cluster are quite close to the centroid, right? So is that a good cluster or not? It is good cluster, and the reason is, well, all the samples are very close to each other, and hopefully all the other samples which don't belong to this cluster are kind of far away from this cluster, and then we have a good cluster, right? So it's the same thing. If you have a very low sum of the sum of the squared sum of the SSE, and then, well, you know that is a very good SSE, and probably your clustering is good. However, when you decrease the number of the k, what is going to happen? Well, if you consider the extreme case, we have 200 samples, and then we are clustering the samples into 200 clusters. What are we gonna have? What will be the total of the SSE if we are clustering 200 samples into 200 clusters? That's a zero, right? So this is the point. So we will always see the SSE decrease when we want to increase the value of the K. So how about we try to do an eyeball method? And this is the part we have already done, and that is if we want to try different k values in the k nearest neighbor, we have already done that, and we want to do the same thing for the k-means. Okay, so I created a list of the SSE, and then I try all the k values from 1 to 40, and for each of the k value, and then I try to call this function. So I'm calling the k-means SSE, and then I want to append the total, the sum of the SSE to the SSE list. Okay, so and then I want to do a plot. Well, as you can see, if the k is 1, and then I'm putting all the samples into one huge cluster, and then, well, you can imagine, well, the SSE is going to be very high. And then when I use 2, and then, well, the SSE drop a lot, and then 3 it drops, and 4 it drops, and what I can see is after 4 the SSE is still dropping, that's for sure. So SSE is always dropping when we increase the k value. However, after 4, the SSE is still dropping, but the dropping rate, the speed of the decrease of the SSE is slowed down a lot, right? So here is how do we pick the k value. So we want to pick the k value where if we want to increase that again, the drop of the SSE is not that significant. Okay, so this is how we can pick the k value. Okay, I guess this video is already long enough, and I'm gonna pause here, and I will see you in the next video.